Webinar is switch from subscription models to fault detection models with the Artesis IIoT condition monitoring. Now, anybody that has kids or been in the world today, everything is subscription based, and you constantly get these subscribe buttons everywhere you go, and it has leaked over into the industrial world where we reside, and condition monitoring, everything seems to be, you can't get rid of these subscriptions and subscribe buttons and, all these ongoing fees. But Artesis Shoreline, we aim to get back to a simpler time, time that makes sense fiscally for your organization, where you get what you pay for, and you don't have ongoing fees to just use and utilize the types of condition monitoring that you already paid for. And Artesis takes a different stance on this and tries to give you a more cost-effective method of condition monitoring, and you get a much quicker return on investment instead of the ongoing fees. You may never catch up to the actual return on those investments. So okay, so Artesis condition monitoring without sensors or subscriptions. What we're going to cover today in the webinar is this technology, a quick history of it, Artesis EMCM's overview. We'll also take a look at the AMT Pro Portable. What is model-based detection, and how does it work? How difficult is it to install and implement? How do you get these programs up and running? We'll talk about some case studies, show you a couple of those towards the end, and again, we'll save a little bit of time for questions and answers and any other concerns that you may have. So Artesis is an affiliated company of Baker Hughes, spun off from GE, but the technology itself is over 35 years old. The original modeling technique was developed by Dr. Armet Duyar, who was a professor at Florida Atlantic University for over 31 years. During his time there, he was asked by NASA to develop a way to detect early on faults on the main engines of those space shuttles. So he had done that, spent a number of years there with him and his team, developed this method, also was able to apply it to the Pratt & Whitney helicopter engines, and then he saw a commercial aspect to this, coupling it with electrical signature analysis, and went back to his home country of Turkey to develop this technology. Spent 6 years from 1999, over 6 years, to 2006, to developing the AI and the model base that is really the part of Artesis condition monitoring that sets us apart from everybody else in the world, that we believe there's really no other technology that couples a powerful electrical signature analysis with the AI and model base that we have, again, born from research done at NASA. The company has had several awards over the years. Again, they're not an overnight company. We see a lot of these companies, kind of popping up saying we can do all kinds of things, all kinds of different monitoring. But they're over 20 years old and just poorly represented here in the United States. But we did a relaunch with them, and now we are growing quite rapidly here in the United States as well. So they do have a global presence. They, again, have been around for quite a while. Offices all over the world, a smaller one here, but we're their main distributor in the United States, with local representatives across the country, parts of Canada, and Caribbean, or Caribbean, however you like to say it. Sampling of some customers, worldwide, to give you an idea. Again, the company has been around for quite a while. But okay, so that's a quick history of it. But what does Artesis do? And no subscription sounds fantastic, but is there any value in it? What does it do? How can we implement this? So let's take a look at an overview of what it does. So it's an effortless CCM. We coined that because it's comprehensive. It does a wide range of things um, as far as condition monitoring on your assets. And it presents that information to you in a very simple format. The reason we don't really require any subscriptions because we don't need third-party intervention or analysts staring at squiggly lines and looking at the data, to give you some feedback, and there's some time delay there. The software and the AI built into it, we're using the model base, is able to automatically identify these faults. So the software is truly doing all the work, the analysis, and presents the information to you in the simple bar graph format or pie charts and other the things that we have. But again, good sampling here. Let me turn on the laser pointer. But the stoplight traffic light configuration, obviously, caution would be in the yellow and red would be the alarm. You can see things have, elevated here to an alarm level. You would get notified by the system automatically by email, and then also on the dashboard. The comprehensive part of that condition monitoring, the comprehensive means, if if you're familiar with vibration, ultrasound, the system is able to automatically identify mechanical faults. And we'll talk about how it does that shortly, but things you would get from vibration, like bearing conditions, and even as far as going and figuring out if it's in a race, out of race, the type of bearing condition, bearing fault that's developing, misalignment, unbalance, structural or component looseness, gearbox issues, belt drive issues, those types of things, all those mechanical faults we get, from monitoring simply the voltage and the current to the machinery. We're also able to identify all the electrical faults, upstream, downstream. So, incoming power supply, supply issues, voltage fluctuations, motor health. So the whole condition of the, rotor, stator, the windings, we're able to see all of that, even corrosion at some terminal blocks at a local disconnect, those types of things. Also process-related faults. So it takes it even further and is able to identify process-related faults, such as a leaking valve downstream, and the motor's working harder to keep up the certain pressure or something like that. Cavitation on a pump. But also you wouldn't see the cavitation in a fan system, in the plenum. You would see different types of faults. So it learns what is the normal process and is able to identify process-related faults. How accurate is this system? We see that it's over 90% accurate from a study done a few years ago. And if you do some research into the electrical signature analysis, you'll see, there's other ways, that or other studies that have been done to prove this, technology through our own research and Artesis. They've done studies where they compare it to other technologies for verification or autopsies on failures. So again, a very high degree of accuracy in its automatic fault detection, which is very high. Now, it also is able to tell you how much these faults are affecting your energy efficiency. So we give you this triple E number, the effects on energy efficiency. So in this example here, it's found loose foundation and components, transmission elements, bearing conditions, and these faults are costing more energy, more power consumption, to do its performance or perform, at its expected values or levels. So 499,000 kilowatt hours multiplied by your local electric rate, it's going to add up. So all of these faults across the board, across your facility, add up to, some pretty high numbers of additional power consumption. You think of, say, just a simple, misalignment, if something's severely misaligned or just slightly misaligned, it takes more energy for that motor to turn and do its job. So of course, a precision aligned machine is going to turn by hand very easily, and it takes less work for the motor to do its job. But any effects have having a greater effect on your energy efficiency. We also double as a power meter. So we're tracking all the runtime hours and kilowatt hours. So all of your, we're tracking and trending all of your power consumption and runtime hours. So you can do all kinds of energy analytics across the board too of all your online systems. And a common question that we get is, okay, you don't have subscriptions, but are you able to pull that data into a third party, say dashboard like DCS or SCADA system? We're wide open with our software. Mentioned no subscriptions, but we also don't even charge for the software. We have a few different versions of the software on premise or on cloud. And we don't charge for those either. They are, the purchase of these tools gives you a lifetime license, upgrades of all the software. But we're also, able to integrate those into third-party systems through OPC tunneling or APIs, SQL database sharing. So a couple of different ways to integrate into third-party platforms. Okay, so here are what the systems look like. Sorry about that. We're going to talk about the technology. We're going to look at, how does the system really work? And just to give you an idea what these systems look like, they mount into the MCC panel. I'll show you an example, a picture of an installation a little bit later. But this is the EMCM motor condition monitor for all your three-phase AC motor-driven assets. Just under 4 inches, almost square, 2.5 inches deep, thin rail mountable, comes with a local display that you can mount onto the MCC panel face. We also have the plant condition monitor, the PCM, which is for generators. So we can monitor generators as well. Same identical looking unit, slightly different internally. And then our new popular AMT Pro, the portable 7-minute measurement. So you can do a full machine assessment in just 7 minutes. So if you picture doing, your vibration routes, walking around collecting data with a data collector, your new route would be in the MCC room. We have test plugs that you can permanently install into the cabinet, so you can just walk up to a machine, plug into it, and run a 7-minute test. And that's not just collecting data, that's analyzing and reporting all of that data. So you can do 35, 45 machines in a day, sync it all up to the cloud, trend all of that data. The main differences between the two, this is obviously 24/7, every second, continuously monitoring and feeding to the dashboard. Also goes through that learning process to get those process-related faults. The AMT Pro, is a 7-minute, measurement, but is able to identify all of your electrical and mechanical faults in just 7 minutes. Again, using that model base and the AI to determine those faults. Okay, so what is behind all of this technology? How does the system really work? Okay, so I'll read through this here, and then we'll talk about it a little bit. So this model-based approach works on the principle that the current drawn by an electric motor is affected by not only the applied voltage, but also the behavior of both the motor and driven equipment. It identifies the distortions of the current waveform that have not been caused by the distortions on the voltage waveform, and therefore must have been caused by the machinery itself, the components of the machinery, the defects. The frequency of these distortions indicates the nature, so similar to vibration, the frequency tells us what the cause of it is, and the magnitude, amplitude, tells us the severity. So in a perfect world, you would have three-phase voltage, perfect sine waves applied to the motor. The current drawn would be a perfect sine wave out, and everything's perfect. But that's not real world. So the graphics on this these waveforms are actually very good, because we always see in the real world we're going to get some harmonic distortions on the voltage side, those are amplified on the current side. So if we're only looking at the current, we could be fooled into thinking we're getting an alarm based on the frequency of these distortions on the voltage side. Maybe it's the same frequency of a bearing or a misalignment. So what the system does is it identifies all of those distortions on the voltage side and filters them out so that the only thing left that can cause these little blips on the current side would be actual defects from the machinery itself. The EMCM, when it's installed, creates a digital twin. I know that's a big buzzword in the AI world today, but we truly create a digital twin. This is how our system has always worked. We put in the motor nameplate information, so it's creating a healthy asset of that particular machine. So whether it's a brand new motor or a 20-year-old motor that's got some faults and really on its last leg, it doesn't matter. We create that digital twin, we duplicate that motor, right? And the system now knows exactly what it should look like. We measure what it actually looks like. We filter out any of those harmonics from the voltage supply. And the only thing left causing faults now are these actual defects from the machinery. Okay, so we have a PSD, the power spectral density, very similar to an FFD spectrum. So we're able to identify these faults, and our system actually uses the same exact fault frequencies that all the bearing manufacturers use with vibration. So it's truly a cause and effect relationship. Since we're monitoring those voltage distortions, those can also affect your motor health. So we track and trend and report any anomalies or anything that breaks a threshold, those THD, total harmonic distortions, and the odd harmonics that can deteriorate your motor, the windings, rotor, stator issues, insulation. So those are also tracked and trended. We're also going to track and trend all the voltage and current fluctuations, voltage and current balances. And we're going to talk about how it learns, and gets these process-related faults as well. Now, a common question we get is, okay, you're monitoring the voltage and the current, so naturally you can get the electrical side of things, but you're installing this unit into the MCC bucket, but my cooling tower is 150 feet away, 50 feet in the air, all the way out there. How can you see a bad bearing on my fan, through the MCC bucket, which is all the way over here? And the answer is, we're using the motor as a sensor. So in the beginning, we said we don't use any sensors. We don't put any sensors out on the machinery. You already have your sensors out there. They're the motors. And actually, more specifically, the air gap between the rotor and the stator. The electromagnetic forces between the rotor and the stator, is where we're listening to all of the machinery and the components in the whole machine train. So if you have a misalignment, you're going to have some eccentricities and some vibration between the rotor stator. If you have a bad bearing on the fan, even through the belts or gearbox or what have you, it's going to hear the whole thing. So for those vibration folks out there, just think of this air gap as a very sensitive accelerometer in every direction, listening to the whole machine train. So even through the belts, through gearbox, it's going to see all of those. So the same, think of it as you're sitting at your desk and you're near a train station. You can tell when the train goes by. You feel it. Maybe you didn't see it, but you heard it, you felt it. That's how the system works. So we can hear everything that's going on in the machine train, and again, that noise, that vibration on the outboard bearing of the fan is creating, that defect. Say it's an interrace defect. It's creating a fault of some kind, and that noise, that vibration, it transmits through all of the machinery, through the belts, into the rotor stator position, and it hears all of that. We run it through the FFT, ultimately the PSD. We get our spectrum, but the system is able to analyze all of that data and tell you what the faults are. Now, the first thing the system does, the EMCMs do, is the model base consists of over 10 million electrical fault signatures. Okay, so that model base is unique to and proprietary to Artesis. And that is really what sets us apart from even electrical signature analysis companies, because the system now knows all these faults. And when you install it, if you have a bad bearing, if you have a misalignment, it quickly identifies those. That's how the AMT Pro works, the portable kit, and is able to find these faults in 7 minutes. The online systems take it a lot further and deeper to find all these faults. So using that model base, the first 3 to 4 days, it's going to identify all of your existing faults and report them to you. Now, after that, it's going to start building these specific math models for that motor and its driven assets. So if you have, say, 2 identical motors and one's driving a pump, that's a very simple system, just on, off, fixed speed, pumping down a tank every time it fills up. And then you have that same exact motor applied to a cooling tower that's constantly hunting around based on outdoor temperatures and loads on the system. You know, they're going to look very, very different electrically. So we cannot apply one algorithm to that specific, motor. Say it's a 50 horsepower motor or whatever. Okay, here's that algorithm for that, no matter what it's turning. No, they're going to look very different. So the system now starts custom building all these math models specific to the process. And all these little clusters are a factor of power factor, gain, supply frequency, and a number of other parameters to start now learning what is the normal process for that particular motor. So now when it's in the full monitoring mode in its normal operation, it's comparing apples to apples all the time based on the different load parameters it saw during the learn period. So that simple system pumping down a tank on off may only have a few dozen of these clusters, and then you have the cooling tower has hundreds and hundreds of these clusters, and so now when it sees the VFD supplying the 52 hertz to the motor, it's going to have a math model at 52 hertz to compare it to, and it won't get confused by running at 32 hertz and only having the data from a 52 hertz. So it's always got a cluster to compare that data to. Now, if it doesn't, or it sees a new operating parameter, you can always update the algorithms and let it learn for another day and a half, and it'll see something different. So like a good example is maybe that cooling tower learned during the summer real high loads, and different operating parameters. But now you're in the winter and it's cooler, much lighter loads, and it's not running as often, and it may not have a cluster built for those particular operating parameters. So it'll see it as different, but it doesn't fall into any default categories. So you simply hit the update button on the software, and it builds more math models. So over time, this thing gets more and more intelligent. Another example is, say, a paint manufacturer. They have these mixers, and a lot of the paints have the same viscosity, so it's very similar. But say they have a new product, or a test product, or a different whatever batch of different viscosity, much higher load, or then you just hit the update button, and now it learns that's a new normal. So next time they do that load, it'll have something to compare apples to apples to. So in recap, the learning period of how the system works is, 3 to 4 days of the learn, where it finds all of your existing faults. For VFD systems, any variable speed systems, we shorten that to about 10 hours. And then the improved mode is 6 or 7 days to build those math models on fixed speed machines. But the VFD is we want to learn more and extend that period, so we give it a full 10 days of math model building. Okay, so the again, the system, very compact yet very powerful. What does it look like to install it on your machinery? Again, we don't have to access your machinery like this here, pretty grimy. Some of your facilities may have some hazardous environments. Maybe in the nuclear world, you have some high dose areas that you don't want to go into, or limit your exposure time. Borehole pumps, deep well pumps, anything that's just maybe impossible to access. Your cooling towers can be, hard to access, or just again, any hazardous environments, or anything that's difficult to access, up on some scaffolding. Our system is very simple. Goes right into the MCC cabinet. We don't have to access the machinery, and very easy to install and implement. Um, we need to get the voltage from each phase, the current from each phase, and power the unit, and then send the data out. Okay, so here we have the power supply supplied to the EMCM, 120 volt power supply. Now let's grab the voltage from each phase. Very simply, 12, 14 gauge wire, right from this, say, terminal block here, and terminate that into the EMCM phase 1, 2, 3. Now you told us the full load amps of the motor. We supply you with the correct sized CTs, which are customized for us. They're clamp on. You just simply open them up, clamp on, plug it into these little clips here at the bottom, and then plug that RJ45 connection into the EMCM telephone jack, basically. So we supply this cable, 3 little clips at the bottom, clamp on, clip in. So maybe this took us 15 minutes. And then the Ethernet communication, Cat6 communication out. If you're using the local HMI, which is not required for the system to work, it's just nice to have a local output. That's powered and gives all the information through the port next to it here. So that's another Cat6 cable. From the EMCM, we need to get the data to our server, or your server. So we can do that a couple of different ways. To get it onto the cloud, we can go through an LTE cellular router, modem router. You could have multiple units, say 20 units going into a switch into the router, get it onto the cloud, and then you just have a local dashboard access. You can also use, if you have some IT infrastructure in your MCC rooms, you could tie it into your local switch, get it onto your local network, and then onto the internet, onto the cloud, if you're using the cloud software. But if you have some cybersecurity concerns and you want to have a completely on-premise software, cut it right off from the internet. You don't need to have cloud access. So I think I don't know of any other system that is fully autonomous that doesn't require cloud access or remote access to be able to analyze the data. Our system, again, is truly doing all of the analysis in the software, so you can have it truly on-premise with no internet access at all. So some really nice options there, on-premise, online. Again, the same cost for each one is $0. Okay, so let's take a quick look at the some live data online in the AMT Pro Portable. Let me jump out of here and let's take a look at the AMT Pro. You can see it here in the top right corner. Before we look at the online dashboard, let's take a look at what it looks like to set up an AMT Pro. I have a unit here. I'm just trying to drag it over. Okay, here we go. Okay, so we have, this is the main screen of your system. So AMT Pro. Here's the app here. We have content with all the manuals inside of it. So let me go into the AMT Pro app. To build an asset, simply click Assets. Go in here. If you want to create a new company, company name, contact person, all of that, let's just say, let's look at this one here. To build, again, a new asset, just hit the plus button. Let's look at one, Blaylock, air handler. Okay, so equipment name, enter the name, whatever nomenclature you use there. Is it a fan? Is it, all these different types of type of machinery, belt or pulley driven, nominal voltage, nominal current, nominal frequency, 60 hertz, full load running speed. The current ratios, that's just the CT ratios that we're using for this particular asset. And then the voltage ratio, connection topology. Once you enter in the motor nameplate information, you click Save. Now you just built a full asset. You're ready to take a measurement. If you have hundreds and hundreds of measurements or assets that you want to use with your AMT Pro, you can use the cloud software that accompanies it, and download the template, the spreadsheet template, and just cut and paste all of your asset information and build hundreds of assets in about 5 minutes. So then we go into the start test. This, if I click on it, it's going to shut off the Wi-Fi because it uses the Ethernet internally to communicate. So we'll go jump right into, say, we run our 7-minute test, and then let's pull up that asset again. Oops, I double clicked. Let's say Blaylock. Okay, so we ran our 7-minute test. At the end of the test, you'll get this pop-up. This is what it'll look like. Your actual report right here, and this is a good example. Triple E number, the effect on energy efficiency. So it found loose foundation components, transmission elements, bearing, totaling 41,373, kilowatt hours. Corrective maintenance action will save that amount in energy consumption. So you can see here we have 3 in the red, and we don't just tell you you have a problem. We also give you some things to go and check and look for. That's page 1. On the second page, we get all of your electrical parameters, but we also have now added your waveforms, voltage and current. You have your harmonic levels, THD reported, so it's 2.6. That's actually a little bit high. Crest factor on the voltage and current, and the phase diagram. So when you initiate a test, what it does is it shows you this phase diagram, this vector plot, and will basically tell you if you set it up wrong, and all of this information as well. So the last part of it is, the actual spectrum. Now here we can do some advanced analysis right in the box. We can also open up the menu and plot out the different fault frequency bearings, and maybe the bar graph said we had a bad bearing here. You can plot out the inner race, outer race, and again, very similar to vibration analysis. And you can plot out, and find out which bearing is in fault here. Looks like this one here is syncing up. Okay, so very good example. From the box, you can do a send a report. So hit the PDF button in the bottom right, and it generates a report, and you can send that right out to, say, a customer or to yourself, for printing out. You can also print right from the box here, share it, email it, right? Click here, click send, and add notes to it, and then save. Okay. So let me back out of here. So that's the AMT Pro, a very popular tool these days, and growing. Now let me show you some live data from the from the online systems here. We have some the live data. Here's the main dashboard. You have your total conditions of everything that's running today, everything that was running yesterday. If you have hundreds of units here, you see something in alarm, maybe watch equipment, electrical issue, mechanical issue. You want to see which one it is and what the issue is. You can click on this diagnosis list, get a quick matrix of all of your machinery, status report of all the machinery being monitored, your total runtime hours and power consumption. Today versus yesterday versus 1 week ago. Total top 3 energy users of the site of everything being monitored. You also have hourly, daily, monthly power consumption. All of this data is exportable. We have a manager's view. I'm going to go through this pretty quickly so we can show you some case studies and save a little time maybe for questions. Manager's view is really meant for, say, like a plant manager wants to get a overall condition of all the site today. How are we running today? We want to see everything green. He or she may not care if it's or they're concerned for a bad bearing or a misalignment. How's my plant running today? So again, on the manager's level. Now let's take a look at the detailed info. Now here, get a quick status of our machinery. You can break this into categories, cooling towers, feed pumps, those types of things. Drop down box of all your machinery. Let's see if there's anything else running here. Active power, all of your electrical parameters here, anything that's in caution will show up with this exclamation point. That's basically something that breached in the past few days. You can see here we breached the threshold the last few days. And then if it stays in alarm, this whole box will turn red. That's a quick trend of it, but we have a whole trending page. Up in the top right corner, we'll get our report. Pull the bar graphs here. You can see this thing's been a little bit troubled since we've been monitoring it. So it does need some maintenance, of course. And then all of your electrical parameters on the electrical parameter tab, anything that's in alarm will show up red there. But you don't have to go looking for all these alarms. We'll notify the system automatically. Will notify you by email. The PSD is our power spectral density. It's a more stable version of the FFT and more accurate using electrical signature analysis in the model base. So we give you a reference of what it saw during the learn, and we take a new spectrum every 10 hours by default. That's adjustable if you need it, but by default, 10 hours is definitely plenty of spectrums to see changes over time, and you can plot those out. Right, so that's like it's like going out and taking a new vibration spectrum every 10 hours. Okay, if we had the bearings numbers installed here, like on the AMT Pro, we could plot out all the different fault frequencies. We can also enter in the belt information, get blade pass frequencies, and gearbox mesh ratios, blade pass, impeller blades. Those types of frequencies. So you can do some advanced analysis, and we do offer 2-day certification classes. The trending page here, I like to add in a quick case study. Whoops, where did it go? So the trending page, you can compare one machine to another. And there we go. Here's a good example of the use of the trending page, again, also covered in some advanced analysis. So this is one of our customers here, developed this, put together this case study for, a trade show they were presenting at, and he happened to highlight the use of the Artesis EMCM. So Monty Sedlak with Jacobs Engineering, full credit to you. Thank you for this presentation, and he has allowed us to share this. So what he saw here, he was alerted automatically by the system of a fault, and the fault code was electrical looseness and short circuits. So he generated a work order for the electrician to inspect the whole system. Using an infrared camera, he found hot spots at the weatherhead and also corroded connections at the MCC bucket. The electrician re-terminated all the connections with fresh copper on the wires and reconnected the weatherhead hot phase. The improved performance of the motor was immediate and sustained, and credits the Artesis system for having found that. Okay, not impressed yet. Let's move on to the next page. Okay, so this system, the electrical fault, also caused a mechanical fault. The same machine selected for bearing conditions showed a dramatic increase in bearing stress. The phase fluctuations caused a mechanical stress on the rolling elements. So again, the phase fluctuations caused a mechanical stress. It manifested a mechanical issue. Okay, so how many times, anybody that's in the service industry or, facilities, we've been, myself and the reps have been doing this a long time. Almost every facility has one or two machines, that, hey, we just replace the bearings, every 6 months or every year because, it's just our trouble machine. We can't figure out why. It's just the way it is. Well, here, we're showing that we're able to also do root cause of why that bearing is failing, right? So the electrical also manifested the mechanical. And it wasn't linear, it was more extreme on the bearing side. After the electrical repair, you can see the bearing also came right back down and was sustained. So it didn't have permanent damage. Furthermore, the energy consumption Monty had calculated out um, and calculated out the total energy savings. So you can see here, before the correction and then ultimately really settling down. And that is a pretty significant energy savings. Keep in mind, this was a very simple correction of re-terminating and cleaning up the copper at two positions, at the weatherhead and the MCC room. So they were able to realize over $7,300 in energy savings just by doing that. Had that had a catastrophic failure, it would have been over $120,000 to repair, replace the whole system. So a really nice case study there. And let me pull this out of here. Okay, so that's a good example of the use of your trending page. You can compare, say one machine to another, pump one, pump two, compare the data from one machine to another. And then the last two tabs on the online systems, monthly analysis, daily analysis of your total assets. It can break it out into all the different categories and show you what's using the most, in this simple pie chart here. You can break it, and look at it each month. You can break it into categories and specifically down to the equipment level. Look at certain machinery itself and see how much time, it's been running, active power, total runtime hours versus power consumption. And then all of this data is exportable if somebody needs to run this through some kind of other algorithm, see total costs. So you can export all of that. Just simply click that button and export that data. Okay. Okay. That is the conclusion of our presentation today. I thank you for all participating and viewing the webinar. That's Artesis in an overview, switching from those subscription models over to our fault detection model with no subscriptions. We have all of your, if you gave us your email information, we can reach out to you. We have local reps throughout the country. Again, if you're outside the United States or outside the Caribbean, you can also reach out to us and we'll get you to Artesis and have their local representatives contact you as well. If there's any questions, feel free to go to the Q&A page and ask any questions that you have. If not, we'll leave this open for a couple more minutes. But again, I want to thank everybody for attending and listening to our presentation, and we look forward to working with you in the near future. Okay, one question coming in. Does the AMT Pro unit require any recalibrations? No, it does not. It's basically monitoring the voltage and current, running it through the algorithms, and does not require any kind of calibration at all. It's also, some more details on the AMT Pro. It's Android driven, so when you turn it on, it automatically updates just like any other app. And easily updated, and those are free of charge for the life of the tools as well. Came a little late. Well, this presentation in an email. Yes, we can share the recording of the presentation with anybody that wants it here. In fact, we'll just put together the list of everybody that gave us their email address and send you the recording if you want to share it, review it again later. Not a problem. Can you elaborate on the difference between the cloud connection and the plant-only connection? The only difference is, if you're cloud-based, you would have a web login, and if you're on-premise, it would just reside on your local server, and you can have your dashboard on your desktop. The software is the exact same. Any other questions? We'll leave that open. Here's a question. Is a PC mandatory for the EMCM to work? Yes, it is. You have to have communication to the server. So the software can show all of the data. So out of the EMCM, it does need a constant communication. The EMCM itself does not store that data. It pre-processes everything, the waveforms and everything internally, and then sends out processed data. So it's very light as far as transmission, and sending the data to either the cloud through an LTE router. It's not going to bog down, all kinds of gigabytes of data. So on average, about 20 EMCMs going through one LTE cellular router would use maybe a gigabyte in a month. That's 20 units. So very light data, but it does need constant communication to the PC or the server. We'll rewatch. Okay, Chuck, sounds good. We'll send that to you. Any benefit to connecting with vibration monitor? Any benefit to connecting with vibration monitor? Not sure exactly what you mean by that, but it is nice, of course, to still have a vibration, say, portable data collector to maybe verify a fault, or if the Artesis system you have says you have an imbalance, you would need the data collector to go balance the machine. So again, maybe just for verification and for some balancing, or finding where your you can do phase analysis to find your looseness or structural looseness. Okay, Chuck, we would like to have, where are you located? Chuck Sprayberry. We would like to have a rep come see us. What protocols are available to bring the EMCM data to PLC? So we communicate through Modbus, and also through OPC tunneling. We have APIs available for all the individual points. So TCP/IP, Modbus communication. Chuck will have somebody reach out to you for a demo to come out and see you. Let's see if there's any more questions. I think that's everything. Feel free to, here's another one. You're welcome, Chuck. Chuck, if you didn't give the your email earlier when you registered, just you can put it in that discussion there now. But if you did already, then we'll have somebody reach out to you. No problem. A few minutes left here. If anybody has any more questions. Okay, thank you, Chuck. Well, if you're still there, Chuck, where are you located? That'll even help us further. Okay, Pasadena, Texas. Awesome, Chuck. Yeah, we'll have the local rep reach out to you. Thank you, Walter. Always a pleasure to hear from you. Okay, here's a more technical question. Is there any limit on sensitivity in an equipment train? If there is a motor, a gearbox, driven equipment, how sensitive will it be detecting faults from the driven equipment or process? So, yeah, very good question. Naturally, as you get further away from our sensor, the motor, the sensitivity gets dampened, right? But 2, 3, even 4 machine trains, not a problem. But if you think of, say, a big motor driving through a gearbox to a roll, at a paper mill, they say that roll is 20 feet long, the outboard bearing, probably not going to hear anything on that, but maybe the inboard bearing, the drive side bearing. So 3, 4 machines, not a problem at all. It's extremely sensitive to all of that information. But yeah, as you get further out, you definitely could get dampened and lose the signal. Okay, I think we're going to wrap it up there. Thank you everybody again for your great questions. Local reps will reach out to you if you want, and we'll send a recording to everybody. Have a great day and rest of your week. Take care.